The Grand Hall of the Galactic Mathematics Conference sparkled like a field of stars. Floating lights danced near the high ceiling, casting a soft glow over the gathered beings from 100 different worlds. The air hummed with quiet conversations in dozens of languages, while translation devices worked overtime to keep up with the excited chatter. At the center of the hall stood Professor Reed, the human representative, trying not to feel small among the towering alien forms. Some had multiple arms that moved in perfect geometric patterns as they spoke. Others floated in anti-gravity bubbles, their delicate bodies unsuited for standard gravity. A few even existed as pure energy, contained within special fields that let them interact with the physical world. "The Earth delegation is late again," whispered a tall, blue-skinned mathematician to his colleague. "What else can you expect from Deathworlders? They probably broke something on their ship." His voice carried just enough for Reed to hear, and the professor pretended not to notice. The main screen at the front of the hall suddenly lit up, drawing everyone's attention. Head mathematician First Class Wilson, an alien from a low-gravity world who had earned his position through centuries of work, floated onto the stage in his support chair. "Distinguished colleagues," Wilson's voice boomed through the hall, "we gather here today to discuss the greatest mathematical challenge of our age, the starfold paradox." The screen behind him filled with equations that seemed to bend reality itself. Numbers and symbols danced across the display, showing a problem that had haunted the galaxy's brightest minds for over 10,000 years. "As you all know," Wilson continued, "this equation holds the key to perfect faster-than-light travel. Solve it, and ships could jump across the galaxy without using any energy. Solve it, and we could reach other galaxies in minutes instead of millennia." Reed watched as the other mathematicians nodded. Everyone knew the stakes. The starfold paradox wasn't just about math. It was about the future of galactic civilization itself. "The Council has decided to offer a prize," Wilson announced, his deep voice echoing through the chamber. 10 billion credits and a seat on the High Mathematics Council to anyone who can solve this equation. The hall erupted in excited whispers. 10 billion credits could buy a small moon. A seat on the council was worth even more. It meant power, respect, and access to the galaxy's greatest mysteries. Just then, the hall's main doors slid open with a loud hiss. Everyone turned to look as 3 humans walked in, their clothes wrinkled and their hair messy. Reed recognized Dr. Mark Thompson, the famous Earth mathematician, leading the small group. "Ah, the Earth delegation finally arrives," Wilson said, his voice carrying a hint of amusement. "We trust your ship's problems have been resolved." Mark nodded, his face red from rushing. "Yes, sir. We apologize for the delay. The gravity stabilizers needed some quick fixes." Several alien mathematicians laughed quietly. It was typical of humans to have trouble with basic technology. After all, they came from Earth, a death world with high gravity, extreme weather, and dangerous levels of oxygen. Most species considered it a miracle that humans had managed to develop space travel at all. "Well, now that everyone is here," Wilson said, turning back to the main screen, "let us begin. The starfold paradox has resisted solution for 10,000 years. The greatest minds of 100 species have tried and failed. Even our most advanced quantum computers cannot process the complexity of its implications." The equations continued to swirl on the screen, taunting them with their mystery. Reed watched as Mark Thompson took his seat, pulling out a simple digital tablet. Several nearby aliens looked at the device with poorly hidden disdain, their own quantum computers and neural interfaces glowing with sophisticated calculations. None of them noticed the small smile on Mark's face as he studied the equations. None of them realized that sometimes the harshest worlds produce the sharpest minds. And none of them knew that their impossible equation was about to meet its match in a human who had learned to see patterns where others saw only chaos. Mark Thompson sat quietly in his chair, his worn tablet resting on the simple desk in front of him. Around him, the alien mathematicians had already connected to their quantum computers. Their neural interfaces glowed with soft light, and streams of data flowed through the air in colorful patterns. "Look at that primitive device," a crystal-based being whispered to its neighbor, its voice crackling like breaking ice. "The human might as well be using sticks to draw in the dirt." Mark ignored the comments. He'd heard worse during his years working with alien mathematicians. Instead, he focused on the equation that filled the massive screen at the front of the hall. The starfold paradox twisted and turned before his eyes, its pattern speaking to him in ways the others couldn't understand. Head mathematician Wilson's voice cut through the quiet murmurs. "The challenge begins now. You have access to the Galactic Computing Network. Use any resources you need. The only rule is that your solution must be provable." The hall came alive with activity. Alien mathematicians dove into their work, their multiple limbs dancing through holographic displays. Some merged their minds directly with their computers, their eyes glowing with calculations. Others formed small groups, combining their processing power to tackle the equation. Mark did something that made everyone around him pause in confusion. He turned off his tablet's network connection. The human has given up already, a floating energy being hummed to its colleagues. Perhaps it realizes the futility of attempting such advanced mathematics. But Mark hadn't given up. He pulled a simple stylus from his pocket and began to draw. His hand moved across the tablet's screen, making rough sketches that looked nothing like proper mathematical notation. He drew waves and spirals, circles that overlapped in strange patterns. Professor Reed watched from nearby, recognizing what Mark was doing. On Earth, mathematicians had learned to see patterns in everything, in the way water flowed down mountains, in how storms formed over the oceans, in the growth patterns of plants fighting for survival. Earth's harsh conditions had taught humans to understand chaos and find order within it. "What kind of mathematics is that?" asked a young alien student who had drifted closer to watch. Its crystalline body sparkled with curiosity. "It's not mathematics yet," Mark replied without looking up. "I'm just listening to what the equation wants to tell us." The student's confusion was clear in the way its crystals shifted colors. "Equations don't speak," it said. Mark smiled, still sketching. "On Earth, everything speaks if you know how to listen. Our world taught us that the hard way." More aliens began to gather around Mark's desk, drawn by his strange approach. Their own complex calculations hung forgotten in the air around them. They watched as his simple drawings began to take shape, forming patterns that somehow seemed to echo the great equation on the main screen. "Impossible," muttered a senior mathematician whose brain filled an entire floating sphere. "The human is working without quantum assistance, without neural enhancement, without even connecting to the network. This is not how mathematical problems are solved." But Mark kept drawing. In his mind, the equation wasn't just numbers and symbols. It was like the weather patterns over Earth's oceans, like the way rivers carved through mountains, like the growth of crystals in deep caves. His Deathworld had taught him to see connections that others missed. "There," he said quietly, adding one final line to his sketch. "Now I can start the actual math." The aliens watched in stunned silence as Mark Thompson, the Deathworlder with his primitive tablet, began to write out calculations that would shake the foundations of their mathematical understanding. The human factor was about to change everything, and none of them were ready for what came next. The conference hall had grown unusually quiet. The usual hum of quantum computers faded as more and more aliens turned to watch Mark work. His hands moved quickly across the tablet's screen, drawing patterns that seemed random at first glance, but held a deeper meaning. "Look here," Mark said, pointing to a spiral pattern he had drawn. "On Earth, we see this same shape in hurricanes, in the way water drains, even in the arms of galaxies. Nature uses the same patterns at different scales." A six-armed mathematician leaned closer, its eyes shifting through different spectrum frequencies as it studied Mark's work. "But what does weather have to do with the starfold paradox?" "Everything," Mark replied, adding more lines to his drawing. "On Earth, we learned that the hardest problems often have simple patterns hidden inside them. You just have to know where to look." He drew another set of curves that crossed his earlier spirals. See how these lines interact. It's like the way ocean currents flow around continents. When two patterns meet, they create something new. The young crystal student from before sparkled with excitement. I think I see it. The equation's energy flow matches your water pattern. Mark nodded, encouraged by the student's insight. Exactly. The starfold paradox isn't just about mathematics. It's about the way energy moves through space. And who better to understand difficult energy patterns than people who grew up on a world that tried to kill them every day? That comment made several aliens shift uncomfortably. They had always seen Earth's harsh conditions as a mark of primitive development. Now they watched as those same conditions proved to be the key to understanding the galaxy's greatest mathematical mystery. Professor Reed stepped forward, his eyes wide with recognition. Mark, that pattern there, it's like the formation of mountain ranges during earthquakes, isn't it? Yes, Mark said, adding more details to his sketch. Earth's plate tectonics taught us about stress patterns and energy release. The same principles apply here, just at a cosmic scale. The hall erupted in whispers as Mark continued to work. His tablet screen now showed a complex web of interconnected patterns, each one drawn from some natural process on Earth. Hurricanes became mathematical functions. River deltas transformed into energy distribution patterns. Even the way plants grew towards sunlight helped explain part of the equation. Head mathematician Wilson floated closer in his support chair, his usual composure showing cracks of curiosity. Mr. Thompson, are you suggesting that your primitive world holds the key to understanding advanced spacetime mathematics? Mark looked up from his work, meeting Wilson's gaze. With respect, sir, there's nothing primitive about Earth. It's a world that forces you to understand complex systems just to survive. Every human child learns about chaos theory just by watching the weather change. He turned back to his tablet, adding one final set of lines. We Deathworlders had to learn these patterns or die. Other worlds might be more comfortable, but comfort doesn't teach you how to solve impossible problems. The alien mathematicians watched in growing amazement as Mark's seemingly simple drawings began to align with their most advanced calculations. But where their quantum computers saw only complexity, Mark saw patterns that repeated throughout nature. The starfold paradox isn't impossible, Mark said quietly, his fingers tracing one of the spirals. It's just asking us to look at space the way Earth taught us to look at everything, as a living, moving system full of patterns waiting to be understood. As he spoke those words, his tablet displayed a completed diagram that made several alien mathematicians gasp. In those simple lines drawn by hand, they began to see what their advanced computers had missed for thousands of years, the beautiful, natural solution to their impossible equation. Mark's fingers flew across his tablet as equations began to flow from his natural patterns. The assembled aliens watched in fascination as he transformed his simple drawings into complex mathematical formulas. But unlike their sterile, computer-generated equations, Mark's mathematics seemed to pulse with life. The key, he explained while working, is understanding that space itself behaves like a fluid. His hand traced a curve that reminded him of waves breaking on Earth's beaches. Just like water, it follows paths of least resistance. The crystalline student, who hadn't left Mark's side, chimed in excitedly. Like how rivers always find the fastest way down a mountain. Exactly. Mark smiled, adding another layer to his calculations. And just like rivers can join together or split apart, space can fold and merge in similar ways. We just needed to see it as a natural system instead of an abstract problem. Head mathematician Wilson's support chair hummed as he moved closer. But the quantum calculations suggest infinite energy would be needed for such folds, he objected. Mark shook his head. That's because you're trying to force space to fold. Look at how tornadoes form on Earth. They don't need infinite energy because they follow natural patterns. Space wants to fold certain ways. We just need to understand those ways. He pulled up the main starfold paradox equation on his tablet, splitting his screen to show it alongside his work. The aliens gasped as he began to merge his nature-based patterns with the ancient formula. Here, Mark pointed to a particularly complex section. This part that's been giving everyone trouble. It's just like how water spirals down a drain. The energy doesn't fight gravity, it works with it. Professor Reed stepped forward, his eyes wide. And if we apply that principle to space-time, the energy requirements drop to almost nothing, Mark finished. Because we're not forcing space to fold, we're just helping it do what it naturally wants to do. The hall erupted in excited murmurs as Mark continued to work. His tablet screen filled with equations that bridged the gap between Earth's natural phenomena and advanced space-time mathematics. Where others had tried to conquer the equation with brute computing force, Mark showed how to dance with it instead. Look at this, he said, drawing everyone's attention to a new pattern. When water hits a rock in a river, it doesn't stop. It flows around it. Space does the same thing around heavy objects. We can use that principle to create stable folds without fighting against gravity. A senior alien mathematician, whose brain filled a floating sphere, spoke up. But the computational models. Forget the computers for a moment, Mark interrupted gently. Think about how a leaf falls from a tree. It doesn't calculate its path. It finds it naturally. Space works the same way. We've been so busy trying to calculate the perfect path that we missed the natural one right in front of us. As he spoke, his equations took final shape. The patterns from Earth, hurricanes, rivers, crystal growth, plant development, plate tectonics, all merged with the starfold paradox. Where there had been complexity, now there was elegant simplicity. Mark sat back, looking at his completed work. There it is, he said quietly. The equation doesn't need solving, it needs understanding. And Earth, our harsh, beautiful death world, taught us how to understand it. The alien mathematicians stared at his tablet in silence. Gone were their dismissive attitudes and condescending looks. They saw now that what they had dismissed as primitive was actually profound, a deep understanding of universal patterns that their advanced computers had failed to grasp. Mr. Thompson, head mathematician Wilson said slowly, his voice filled with awe. I believe you've just revolutionized our understanding of space-time itself. Mark smiled, thinking of his home planet with its storms and earthquakes, its flowing rivers and growing forests. No, he replied. Earth did that. I just listened to what it was teaching us all along. The tension in the conference hall could have been cut with a knife. Mark's solution sat displayed on both his simple tablet and the grand holoscreen, where it had been uploaded for verification. The most powerful quantum computers in the galaxy were now checking his work. Head mathematician Wilson floated in his support chair, watching the progress bars advance. The first layer of verification is complete, he announced. No errors found in the basic mathematics. The crystalline student who had been following Mark's work sparkled with excitement. Of course, there aren't any errors. It's so elegant, like watching water flow downstream. Several senior mathematicians shot disapproving looks at the student's outburst, but Mark noticed some of them nodding slightly. His solution did have a natural elegance to it, unlike the forced, computer-generated attempts that had failed before. Second layer of verification complete. Wilson continued. The energy calculations are, this can't be right. He paused, his multiple eyes blinking in sequence. The energy requirements are less than 1/1,000,000th of what our best theories predicted. Professor Reed stepped forward. That's because we were fighting against space-time instead of working with it, he explained. Think of it like swimming. You can waste energy fighting the current, or you can use the current to help you move. The great quantum computers continued their work, their crystalline processors glowing brighter as they tackled the more complex aspects of Mark's solution. The alien mathematicians watched in silence, their earlier dismissiveness replaced by growing respect. Third layer verification complete, Wilson announced. The solution is stable across all 11 dimensions we can measure. He turned all his eyes toward Mark. Mr. Thompson, would you explain to us how you arrived at this particular approach? Mark stood up, feeling the heavy gravity of the conference room, so much lighter than Earth's pull. On our world, he began, nothing exists in isolation. Every pattern is connected to every other pattern. The way clouds form is connected to how continents move. The shape of a river delta mirrors the structure of a tree's branches. He gestured to his equations on the main screen. These aren't separate formulas. They're all part of the same pattern. Just like on Earth, everything is connected. We just needed to see the connections. The floating sphere brain mathematician spoke up. But how did you know which patterns to connect? Our computers analyzed billions of possibilities. That's exactly the problem, Mark replied. You were looking for the most complicated answer because that's what your computers do best. But nature always finds the simplest path. Earth taught us that the hard way. Final verification complete. Wilson interrupted, his voice filled with awe. The solution is perfect. Not just mathematically correct, but perfectly optimized. It's as if it was always there, Mark finished. Just like how water always finds the perfect path downhill, or how lightning always finds the best path to the ground. We didn't need to create a solution. We just needed to discover the one that nature already had. The hall erupted in excited discussion. Mathematicians who had looked down on primitive humans just hours before were now crowding around Mark's desk, asking questions about Earth's natural patterns and how they could be applied to other problems. The crystalline student's voice cut through the chaos. Does this mean humans will teach us about other patterns too? Wilson raised his appendages for silence. Mr. Thompson, he said formally, your solution will be recorded in the Great Library of Mathematics. You have earned both the prize money and your seat on the High Council. But more importantly, he added, his voice softening, you have taught us all a valuable lesson about the wisdom that can be found in unexpected places. Mark looked at his simple tablet, thinking of the stormy world that had given him these insights. The universe speaks the same language everywhere, he said quietly. Earth just taught us how to listen. 1 month after the breakthrough at the Galactic Mathematics Conference, the universe had changed. Ships across the galaxy were being fitted with new starfold drives based on Mark's solution. What once took years to travel now took days. What once took days now took minutes. Mark stood at the window of his new office in the High Council Tower, watching ships fold through space as naturally as birds gliding on air currents. Each fold followed the patterns he had discovered, the same patterns that Earth had taught him through its storms and rivers. The latest test results are in, Professor Reed said, walking into the office. The new drives are using 99% less energy than the old ones. Some species are already talking about exploring other galaxies. Mark nodded, thinking about how far they'd come. And what about the other research teams? That's the most exciting part, Reed replied, his eyes bright with enthusiasm. Scientists across the galaxy are starting to study Earth's natural patterns. They're finding applications everywhere, not just in space travel. He handed Mark a data tablet showing various projects. A team of alien architects was studying the structure of beehives to design better space stations. Medical researchers were learning from the way rivers branch to understand blood flow. Even alien farmers were copying Earth's weather patterns to improve crop growth on other worlds. They're calling it Deathworld science, Reed said with a smile. It's becoming the hottest field of study in the galaxy. The crystalline student, now Mark's official apprentice, sparkled into the room. Master Thompson, the quantum engineering team just discovered something amazing. They studied the way Earth's tectonic plates move and found a better way to build quantum processors. Mark turned from the window, grinning at the student's excitement. What did they learn? That stress patterns in crystals follow the same rules as continental drift. The student chimed happily. They can now grow quantum crystals 10 times faster by working with the natural patterns instead of forcing them. A soft chime announced another visitor. Head mathematician Wilson, floating in on his support chair. Mr. Thompson, he said formally, The Council has reviewed your proposal for the new Galactic Institute of Natural Mathematics. Mark held his breath. He had spent weeks preparing that proposal, hoping to create a place where humans and aliens could study together and learn from each other. The Council has not only approved it, Wilson continued, his eyes twinkling, but they want to build it on Earth. They believe students should experience the patterns of your world firsthand. On Earth? Mark asked, surprised. But the gravity, the weather. Exactly, Wilson replied. We've been hiding from challenging conditions for too long. It's time we learned what your Deathworld has to teach us. The crystalline student sparkled even brighter. Does this mean I'll get to see a real thunderstorm? And mountains? And oceans? All of it, Mark assured them. Earth may be harsh, but it's the best teacher we've ever had. Professor Reed checked his tablet again. The applications keep coming in. Scientists, mathematicians, engineers, everyone wants to study Earth's patterns now. They're starting to understand that complexity doesn't always need complex solutions. Mark turned back to the window, watching another ship fold gracefully through space. We spent so long trying to conquer nature, he said quietly. All we really needed to do was learn from it. Wilson's support chair hummed softly. The term Deathworlder used to be an insult, he mused. Now it's becoming a mark of respect. Your world's harsh conditions didn't just create survivors, Mr. Thompson. They created teachers. The crystalline student moved to the window, watching the ships with Mark. Master Thompson, it asked, do you think there are other patterns we haven't found yet? Other lessons Earth can teach us? Mark smiled, thinking of his home planet's endless variety, its constant changes, its beautiful complexity. More than we can imagine, he replied. We just have to keep listening. 1 year after Mark Thompson solved the starfold paradox, Earth had become the galaxy's most popular destination for academic study. The new Galactic Institute of Natural Mathematics stood tall against the backdrop of the Rocky Mountains, its architecture following the same patterns as the snowflakes that fell around it. Mark walked through the Institute's main hall, where students from 1,000 worlds studied under Earth's heavy gravity. Some wore exoskeletons to handle the weight, while others floated in protective bubbles. But all of them had come to learn what only a Deathworld could teach. The first graduating class will be ready next month, Professor Reed said, falling into step beside Mark. Every single one of them has made a breakthrough in their field using Earth-based patterns. They passed a classroom where a floating energy being was teaching a lesson about hurricane formation and its applications to energy distribution. Next door, a group of crystalline students studied the growth patterns of Earth's cave crystals, applying those principles to quantum computing. Did you see the latest news from the Andromeda expedition? Reed asked as they walked. Mark nodded, still amazed by how far they'd come. The first ships using his starfold drive had reached the Andromeda galaxy in just 3 weeks. They found habitable planets already, didn't they? Better than that, Reed grinned. They found other Deathworlds. Different from Earth, but just as harsh. The galaxy is calling it the Crucible Theory, the idea that the most challenging worlds produce the most innovative thinking. They reached the Institute's observation deck, where students often gathered to watch Earth's weather patterns. Today, a massive thunderstorm was building over the plains, its formation exactly matching the equations Mark had used to solve the starfold paradox. The crystalline student, now in its final year of study, sparkled excitedly as it approached them. Master Thompson, my research team just made a breakthrough. We applied river delta patterns to information flow in quantum networks. Data transmission rates increased by 300%. Excellent work, Mark smiled, remembering how far his first student had come. What inspired that connection? The last flood season. The student chimed happily. Watching how water found new paths reminded me of data packets seeking routes. Nature had the answer all along. We just had to watch and learn. Head mathematician Wilson, who now spent more time on Earth than at the Central Galactic Library, floated up in his support chair. The Council has reviewed the latest statistics, he announced. In the past year, we've seen more mathematical and scientific breakthroughs than in the previous century, all thanks to what we've learned from Earth's patterns. Through the observation window, they watched as the thunderstorm grew, its lightning illuminating cloud formations that mirrored the structure of galaxies. Students from dozens of worlds recorded the patterns, each seeing different applications in their own fields of study. The funny thing is, Mark said, watching the storm, humans used to think we were behind other species because we came from such a harsh world. We never realized our greatest weakness was actually our greatest strength. A strength you've shared with the entire galaxy, Wilson added. The term Deathworlder is now used in academic paper titles as a mark of excellence. The crystalline student turned its facets toward Mark. What do you think the next big breakthrough will be, Master? Mark watched as rain began to fall, each drop following perfect mathematical patterns as it descended. That's the beauty of it, he replied. Earth never stops teaching. Every storm, every river, every crystal formation has something new to show us. We just have to keep watching, keep learning. Professor Reed checked his tablet. Speaking of learning, the new semester starts tomorrow. We have students coming from twice as many worlds as last year. Good, Mark said, smiling as lightning split the sky. Because Earth has plenty more lessons to teach. This is just the beginning. The storm raged on outside, its power and beauty a reminder of why humans had grown so good at solving impossible problems. In its violence was perfect harmony, in its chaos was perfect order, and in its patterns were the answers to questions the galaxy hadn't even thought to ask yet.